Nice to see some friendly faces here. I'm Haurog. I'm a physicist turned software engineer and now full-time in Ethereum, but not associated with any project.
Hello, I'm Avegot Johan. I'm a software engineer as well. I'm an Ethereum hobbyist, and for the past few years, I've been trying to make Ethereum work on various and exotic hardware that we'll be talking about. Thank you for being here.
So when we did this presentation, prepared it, we were thinking, okay, there's two kind of audiences here. It's home stakers. They might be interested into power efficient hardware, how to get their setup started. But there's maybe also some software engineers here who are interested in the RISC-V platform. So we'll talk about that as well. And how this came about, in last summer, in July, Avegochi made a call, hey, who wants to bring consensus clients and execution clients onto a RISC-V platform? I knew him from before in Discord. I joined him, and since summer we started compiling clients, running them on these platforms, and then we saw that also the Ethereum on ARM team is working on this possibility, so we teamed up with them a bit. So it's Diego and Fernando from the Ethereum on ARM team. There's also Leonardo Arias, he's associated with Flashbots, who was part of it, and then it's the two of us who are independent of any project. So let's get started with ARM boards. Why would anyone want to use ARM boards? Actually, they're quite nice because they're all on one board. So you have the RAM on it, you have everything on it, it's just one simple device. They're low power consumption, and it's a well-balanced hardware if you choose the right one. So it's a good CPU, enough RAM, and you can get running. The problem is it's a steeper learning curve getting Linux to run on them. It's a software support and generally is not on par compared to Intel NUCs or anything like that. And sometimes the availability is a bit difficult, so if a new board comes out, it might be sold out for weeks or even months. Most people think about the Raspberry Pi. It's a nice ARM board. It's good. It's available in almost all the shops. It's cheap and has very good Linux support. The problem is they don't have enough RAM. The CPU is just barely fast enough. And you need an additional board to attach an NVMe SSD. So it's possible to run a node on them, but not the best choice nowadays. The good ones are the ones we use, and also Ethereum on ARM suggests to use. They have all the same RK3588 CPU. They have either 16 or 32 gigabytes of RAM. It's Orange Pi 5 Plus, Nano PCT6, or the ROG 5B. Somewhere between $120 and $220, depending where you get them. Important thing, always buy an official power supply, because the ones you have at home, they most probably won't work, and that's a pain. You'll have to add an SSD, which has the right size, and please also use a Linux specifically made for these boards, like the Ubuntu from Joshua Reeks or Ethereum on ARM. CPU performance-wise, you see a small comparison here. We have Intel and AMD CPUs, which you might have at home at the bottom. Then you have the Orange Pi Plus in the middle, which is about 2 to 3 times lower performance than these high-power ones. The Raspberry Pi 5 is another factor of 2 slower, and the Raspberry Pi 4, yeah, as you can see, we probably shouldn't use that one. I ran a validator on it, a validated node on Ethereum mainnet. Without the validators, we saw the node used about 5 to 8 watt. The CPU usage was about 25% at peaks. And yeah, RAM was about 50% filled, so it was 8 gigabytes was filled. When I directed a few nodes, a few validators to it, power usage was slightly higher, but more or less the same. CPU usage increased to about 40%, and RAM was pretty much the same. Interestingly, when I looked at attestation efficiency over the day which I used it, it was pretty much the same as on my high power node I had before. So you can totally run an Ethereum full node on one of these devices. So with this, I give it over to Avegotchi.
Thank you. So some tips and tricks. First of all, the ARM boards and also the RISC-V boards are fragile. They will always come without a case. You need a case to protect against dust and other unwanted electrical short circuits like your hands. An active cooling, it's always required because the CPU will spike most of the time, and you'll get better performance and actually better power usage, including the small power usage of the actual active fan. So you'll not lose in power performance. Also, an important part is the NVMe. For these small boards, just take the good enough NVMe SSD. Do not go overboard. Always check that the PCI controller is on the exact PCI controller that the NVMe supports. If you buy a PCI Express version 4 NVMe and you put it in a PCI Express 2 controller, it's a waste of money. Also note that the PCI Express 4 and 5 are very, let's say, power hungry. They need better cooling. And also note that if you have a 4 terabytes in the future, that also will need better cooling because the chip surface, it's directly proportional, so it's twice. Also, related to overclocking the CPU, it's worth it. But just make sure that most of the time, if you increase the frequency by 5%, you will basically increase your power consumption by a factor of 2, maybe 10%, maybe more. So just make sure that you take that into consideration. Also, an important part, the ARM boards have CPUs that use the big little architecture. So for example, the Orange Pi has 8 cores, but 4 are performance, 4 are low performance / efficiency. So in some cases, you might want to pin the consensus client on the more performant CPUs, because that one will be used more than the execution layer. Day 2 operations. Okay, I have it all running, all installed. What to do next? So it's important to choose a very good distribution like Ubuntu or Debian-based. Also to have a well-maintained staking framework like DAppNode. ETH Docker is my favorite choice because most of the time the base OS that comes from the manufacturer has very low capabilities, low set of libraries. So if you have Docker, you basically borrow everything from the community via Docker. So that's why I'm very fan of ETH Docker. Also, make sure every time that you firewall-proof your system if you have an at-home staking rig, because you might have a public IP without knowing it. So if you actually have a public IP, you need to find out if you have it and firewall it, making sure that it works. Also, I have there are kernel live patching that is very important to sleep well at night. For example, Ubuntu supports it is free for up to 5 machines. Also, VPN for management. WireGuard is a very cool Linux technology. It can create very fast, very efficient peer-to-peer tunnels. Also, Tailscale or OpenVPN is good. If you have enough RAM, monitoring with ETH Docker makes sense. Also, if you have a lot of boards like I have, it's worth to invest in a small UPS. Also, if your electrical grid is failing you, it's worth the investment is worth. So the summary on short. I'm using it also as a solo home validator on ARM64, but I would suggest to start first using them as a fallback node, a normal Ethereum node. You can run multiple testnets on them. It's just a matter of RAM sometimes. And of course, play with hardware before investing in a very big staking rig. It's best for that. Let's go to the RISC-V boards. So RISC-V has quite a, let's say, young history. It's a young alternative to x64, ARM64 instruction set. The standards are already in place, and the most important part is that it's free open source. So everything there comes royalty free. It's collaborative, and in theory, it should achieve a way faster innovation rate, which for us means lower prices in the future. Lower prices, better efficiency. So we are somewhere in the middle at the moment. What's hard has been already done with the RISC-V foundation and all the standards that are already in place. And important is that we are at a big effort. So a lot of hardware, software companies need to come together and make it as performant, as efficient, as available as the ARM64 and then the x64. The mainstream usage will come at a stage when you will be able to move any workload from x64 to ARM64. You can almost do it for ARM64, x64 right now, and then to RISC-V. So basically, you'll have 3 alternatives. That would be the goal. Okay, so we started with the Litchi Pi 3.8 to this year, Banana Pi F3, 16 gigabyte of RAM, ballpark $150. And then, okay, can I run a staking node on this board? Can I? The answer will be given in a moment, but you can see that there's a long way till it will see parity. So currently, these are the most advanced boards on the market, or the advanced CPUs, which are affordable. Thank you.
Perfect. So then I continue what we did. We tried and built all the clients that are available. I don't go into all the details, but I pick a few. It's like Geth, the execution client. It's just beautiful. You build it on RISC-V. It works. It runs. No code changes necessary. What we did with the consensus client, like Nimbus, it was good to see. We just had to change 5 lines of code, maybe. Or added a target, it compiled, it ran. Code is now upstream to the main branch, and it's in there now for 2 months, so anyone can build Nimbus on RISC-V boards. Another one is Lighthouse. A lot of libraries are not compatible with RISC-V, but we made them work with a few hacks, which we have in local forks of the repository. We didn't upstream it back yet, all of them, but we can run it locally, the stuff. But so, as you see, many other clients are just in different states of non-working, so there's still a lot of work to do. But the nice thing is there is progress. For example, last Friday, Peter Silagi tweeted out that Geth has now a target added, so they build a Docker image for RISC-V now regularly. Then we ran the clients on various networks. We used Ethereum mainnet, Holeshki, Sepolia, testnet for Ethereum, and also the Chiado testnet, which is a testnet for Gnosis chain. We first ran the clients on both clients on one board, like Nimbus Geth and Lighthouse Geth, and as you can see, an Ethereum mainnet and Holeshki, it's kind of, they can't really sync up. They might sync up to the tip of the chain for maybe a few minutes, lose sync again, and then not in sync for half an hour, and then sync back up again. Nice thing is, Sepolia works. Syncs up, is stable, perfect. Unfortunately, we can't run validators on there. It's a permissioned set. So we went to Chiado testnet and tested it there. We ran a validator. It was stable enough. We can see it later on. When we did the split clients, so like only one client on the RISC-V board to see if it runs better. If you only run the consensus client on the RISC-V board, you see in the lower part of the table, it's actually the same picture. So it seems like the consensus client is a bit limiting. But the nice thing is, if you run Geth on the RISC-V board, you can easily sync Ethereum mainnet when the consensus client is on another board. So it looks like consensus clients are the limiting factor, especially on large networks. So if you have the validator set is huge, these boards are limited. And here is an example for a validator on the Chiado network. What you see here in these graphs, it's the CPU performance, CPU usage over time. On the left side, it's just normal operation of a validator node. You have some spikes, which are most probably epoch boundaries. And if you have a sync committee, you have the CPU usage goes up to about 50%. It's very stable, and it uses about 5 GB of RAM. And overall, it's about 4 to 5 watt of power used for this operation. So as you can see, it can do all the duties, and the most beautiful part, that's from the block proposals we did on the Chiado network, continuous block proposals, no outages, nothing. And if I look at the rewards we get, they are comparable to what other validators get. So the attestation efficiency is great on these boards, on the testnet. But what we need better hardware. Companies working on that. In the next 1 or 2 years, we'll get there where we need it to be. We need to get the clients ready. We need a node setup tool like ETH Docker and Setch ready, but obviously they're only working on that once the clients are there. And more importantly, for software engineers, we need to get some of the cryptography libraries implemented in assembly for RISC-V, which is a nice task if you like this kind of stuff, because it's not very often in your lifetime as a software engineer that you can get the chance to start from scratch in this kind of assembly code. But a little bit further in the future, what could be amazing is like CKVM. They're mostly designed to run on RISC-V instruction set architecture, so depending what kind of path we take in the future, one could imagine that these kind of CKVMs run natively on the RISC-V CPU, which is would be amazing. So to summarize for the RISC-V boards, if you want to run an Ethereum mainnet node, don't do that, it doesn't work yet. If you want to run a testnet node, it kind of works. Maybe not the best choice. But if you want to play with hardware, if you want to improve the clients, if you want to write code for RISC-V, or maybe have a glimpse into the future, it's amazing to play with them.
Thank you. So here is a Ethereum future that might affect the small validators, the small boards that we are trying to make work. So the 4 terabytes requirement might be coming sooner than later. So that might, 4 terabyte means double the price, almost the price of the board itself. Also, Verkle, from the discussions at this conference, I understood that Verkle might put strain on the CPU. So the CPUs that we already have that are already working with Verkle might not work anymore. We need a lot of testing to do it, to actually confirm or infirm this thing. Also, if and when the staking requirement will become smaller, that will be a boon for this kind of home validators. So it will be great. Also, if the maximum Ethereum balance for a validator goes up, then it will be less chatter on the network. Again, they will work better. As a conclusion, for now, there is quite a large set of boards that work. They are working in production. They are already working for 1 year or 2 years already. And some of them might fit a home staker needs today. Other we are waiting for the next iteration of ARM64 and also RISC-V to see where this goes. Again, contributions are welcome for the work that needs to be done, mostly in the assembly implementation of the crypto primitives. That's, in our opinion, that it's why the RISC-V cannot sync Ethereum on all nodes. And of course, it would be great to verify more RISC-V boards. Thank you very much. We have a set of links on the presentation, if you download the presentation.
Okay, cool. I'm going to push you guys this way so I can join you on stage and we can handle questions. Okay, thank you again so much. We'll start from the top. Again, QR code here. You can also collect a card to indicate that you've shown up here. But first one, how much disk is necessary to contain the Ethereum blockchain for the next year?
So currently is borderline on 2 terabytes. Of course, it depends on each client slash so execution slash consensus layer clients. So I think without.
Sorry, I'm getting asked to push you guys more.
So without the Verkle implementation, we'll expect it in 1 year or 2. Maybe faster. It depends also, again, on the Ethereum usage, right?
Okay, perfect. In your experience, what's the biggest factor for missed attestations? Network, SSD, or CPU?
I can continue on that. I saw a direct example on ARM64 is the CPU. Basically, if I overclocked a little bit the CPU, it worked perfectly. So yeah, from my experience, CPU.
Obviously, it depends on the node setup you have.
Yeah.
When I support node operators, most issue these people have is with the SSD, which then, yeah, influences attestation rates, but sometimes in a weird way, so it's hard to track down. But it really depends on the setup where the bottleneck might be.
Yeah, if you have any good enough NVMe slash network slash CPU, that's no issue at all. Depends where the borderline is. So.
Okay. How important is 32 gigabyte versus 16?
Shall I take it? Okay. 16 is perfectly enough for normal operations. If the network is non-finalizing and you run the Ethereum mainnet node, it's your main node for staking, you might be part of the problem because your node might go down. As a fallback node, that's most of the time no issue. So 16 gigabyte might be enough depending on what exactly you do, otherwise I'll go to 32.
So I mentioned also in the presentation, if you want to have performance monitoring and other, let's say, small utility stuff there, 32 is way better because you will have a lot of more space to put more applications that can help you on the long term.
Okay. What possible avenues can one explore if they want to contribute to ETH compatibility on ARM or RISC-V platforms?
That is a very open-ended question. It really depends on your skill set, what you want to do, and in which part you want to contribute. Like, there's all the clients, most of them have issues. So it's different programming language, different kind of issues. For some, it's, as far as we understand, issues with the Linux kernel, which needs to be changed specifically for these boards. Like for RETH, you have to do that. For other ones, it's probably implementing assembly code stuff. If you like to do that, one can do that. Yeah.
There are also more powerful boards, but they are prohibitive in price. They're like $1.5K. That might be able to run it at this moment. Like making abstraction of that there's no assembly code for the crypto primitives. So if someone can has access to that kind of hardware, it would be great to know the results. The code already works.
Okay, I just got a sign that said time's up. So thank you guys so much for joining. If you have, there are additional questions here, so feel free to meet them on the side. There's actually also a function on this to give speaker feedback, so do that and watch out for that too.
Perfect.
Thank you so much.
Thank you.
Thank you.
Thank you.